Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787-900 into flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 14 for an ILS localizer. Landing, so right now I'm in the cockpit for the pre-takeoff preparation of the Quality Wings 787-900 in Microsoft Flight Simulator X. I'm gonna show you the cockpit instruments that displays the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, and the barometric pressure of the outside atmosphere. The altitude selected from the autopilot and flight director system panel, and the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute. That also determines the trigonometric angles in degrees the aircraft can climb or descend, the steepness of the trigonometric angles it can climb and descend. So we're gonna have all the information displayed in the primary flight display. Also we have the artificial horizon with the pitch altitude and with the pitch indicator and the bank angle. Also you can see also the flight director, the ILS localizer with the horizontal localizer and the vertical glide slope, and also the ILS localizer crossbars, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode associated with the autopilot and the auto throttle. Later on, vertical navigation modes. So you can see here everything you need to have about this aircraft. The display, the navigation display over here, the computers that we have, screens, the navigation display and the primary flight display, the airspeed selected, also the barometric altitude. So I will start the explanation. We have also the navigation display. The navigation display that displays the terrain and weather reflections from the weather radar, the terrain map. We have the airports, the waypoints, our navigation fixes. We can use for the flight plan we create using the flight management computer. So I'm gonna show you how to create the flight plan using the flight management computer. So we'll input all the data we need for that. So we have also the NDPs, the ADS, the workstations, and the terrain map with the elevation of the terrain around you, so you can look if you have a mountain close to you with the red, green, and yellow, and the display of the airport names. We have also the vertical deviation display that displays the vertical flight path of the aircraft that we have created using the flight management computer. This control display unit that I'm gonna show you in a while. So we'll input all the data of the aircraft we need for takeoff, like the gross weight, that includes all the empty weight plus the passenger plus the cargo, and then we have also the fuel on board that includes the taxi fuel, the reserve fuel, and the trip fuel. So we're gonna have the gross weight of the aircraft for takeoff, the flap settings for takeoff, the mineral dynamic core position, the MAC, and the horizontal trim stabilizer of the aircraft. For takeoff is gonna be calculated using the flight management computer automatically. So this is gonna give the takeoff speeds, the V1, V-rotate, and V2 included. We have the runway we're gonna use for takeoff, the runway length, the runway slope, the conditions of the runway, if it is ice, dry, or wet, the wind direction and speed, the barometric pressure, barometric altitude, and also other information that we have. We're gonna use. So this will give us the takeoff speed, V1, V-rotate, and V2. We're gonna have also the flight management computer. We're gonna create a flight plan or flight path of route. We're gonna input the departure airport and runway, the destination airport and runway. We're gonna have the seats, the other instrument departure, waypoints and fixes, navigation fixes for horizontal and vertical navigation of the aircraft after initial takeoff and climb. We're gonna have the climb to the cruise level, the cruise, then the descent and approach and landing to the destination airport. We're gonna have the ILS localizer is gonna guide us. We're gonna have the stars, the other terminal arrival and fixes, and we're gonna have the ILS localizer to guide us in the destination airport and runway heading and horizontal localizer and vertical glide slope using the instrument landing system. So you're gonna see also that we're gonna tune that automatically when we select the destination airport in the flight management computer. We can do it manually using the radio management panel. So you're gonna see here all these things. You can see inside the cockpit of the 787. We have also the head-up display here. So this is the primary flight display with the airspeed and the altitude, the navigation display with the terrain map and the flight plan we have created here using the flight management computer. This also gives information to the autopilot and flight director system panel and the auto throttle of the Boeing 787 aircraft. So we have also the overhead panel. So we're gonna have all the information we need. We're gonna have a complete flight of the Boeing 787. We will continue after that. I'm gonna show you the autopilot. We're gonna have the flight plan displayed in the navigation display with a pink line. You're gonna see that. At the launcher, we have also the autopilot and flight director system panel that includes the autopilot engage and disengage switch, the auto throttle left and auto throttle right engage and disengage switch, the flight director engage and disengage switch. We have also the airspeed select node. We can select an airspeed nautical miles, knots or max speed, and this will give a command to the engine's thrust auto throttle system and the FADEX. The FADEX are the full authority electronic control computers. One installed per engine to one channel redundancy, one channel phase. The other takes over, control monitors, displays all the functions of the engines. You can see in the navigation systems display, the upper ACAS engine indication controller system display. We have the N1, which is a low speed starter, low pressure compressor and turbine of the turbofan to engine, the exhaust gas temperature, the fuel flow. The fuel flow per engine per hour, 1000 kilograms, 1000 pounds. Also the N2, which is the high speed starter, the high pressure compressor and turbine of the turbofan to engine, the pressure, quantity and vibration of the engine. So this will command the engines, the FADEX and the electronic engine control of the engine. So we have this when we command the airspeed guidance from the autopilot flight director system panel, and the auto throttle zone will command the airspeed rating of the aircraft in flight from takeoff, climb, cruise, descent, approach and landing, depending on the altitude of the aircraft in flight and its configuration. So we're gonna see also that. We're gonna have the airspeed selected here. We have two main modes of airspeed guidance. We have the fixed thrust mode, in which the airspeed is being fixed while we climb or we descend. We have maximum continuous thrust for climb or idle thrust for descent, and this way the airspeed is being adjusted by varying how fast the aircraft will climb or descend to the target altitude we have selected in the autopilot flight director system panel by varying the horizontal trim, the horizontal tail trim position in degrees, or giving it on elevator up or down, nose up or nose down. Pitch command using the autopilot and the auto throttle. We can do also that manually using the flight control, so I'm gonna show you right after that. So we have also the variable thrust mode when the aircraft is cruising horizontally, like in the cruise level or is in approach and landing condition. We have the airspeed adjusted by running the thrust adjusted by the engines. We have also the bank angle limit, the heading select node, the heading hold switch, the heading guidance of the aircraft. We have the vertical rate of climb descent of times hundreds and thousands feet per minute, or the steepness of the trigonometric angles in degrees. You can climb and descend. And also the altitude select node, then the altitude hold switch and the VOR localizer for the Lszh localizer approach capture, and also the approach switch for the auto-on function of the Boeing 787-900 model. So I'm gonna show you that. Then I'm gonna show you the thrust levers, how to use the thrust levers and the flight controls of the aircraft. You can use the flight controls, the flaps, the slats, the overhead panel. We have the electrical left and right engine IDZ, the great drive generator from the left and right engine, the batteries. We have the hydraulic system, so I'm gonna show you that. We're gonna make an engine start demonstration, and we're gonna make, after the engine start demonstration, I'm gonna make a complete flight of this aircraft from takeoff, climb, cruise, descent and approach back to the airport for landing. Let's localizer. I'm gonna make a lot of manual flights. So we'll continue now with this. You can see here. So this is the autopilot and flight director system panel. You can see the airspeed selected 200 knots. The modes, flight level change, LNAV and VNAV, climb continuous, auto throttle, the flight director here, on and off. The autopilot also, the auto throttle left and right, on and off. Autopilot disengage like this. So if we arm the autopilot, we cannot arm it right now, so we'll turn off both of them. We have also the heading, the bank angle limit. We will select a heading of the runway for takeoff. The airspeed, maybe we'll use a little bit more airspeed here. And the altitude. So we have also the vertical speed. I'm gonna show you later that the vertical speed. So you can see now we have here the thrust. We have the modes here selected. We don't have on the flight director. We can turn on the flight director and the auto throttle. The autopilot is disengaged right now. So we have some modes. We have the flight director on. The vertical speed is off right now, with the airspeed 252 knots and the altitude selected. The pitch altitude. So I'm gonna show you now the flight controls and the thrust levers, and then we're gonna make complete flight from takeoff, cruise, descent, approach, and landing. So I'm gonna start now showing you the flight controls of the Boeing 787-900. I'm gonna start with the side stick. We can control the simulation with the side stick. I can climb and descend the aircraft using the horizontal tail, the elevator for pitch up and pitch down. Also use the ailerons and the spoilers in the left and right wing to make bangers, and also use the rudder pedals for the vertical tail rudder to make yaw turns to the left and right. Also the nose wheel steering. So I will show you now that you can see here we can climb and descend like this. So you can climb like this, you can descend also, you can make turns to the left and turns to the right. So it will be like the way we control the aircraft. So you can see both sides are interconnected, the left and the right side of the Boeing 787, just like everything is like the 777 aircraft, the Boeing 777. So you have full control of the flight controls like this, as you can see. Hope you like the way we control the cockpit flight controls. And we need so you can see the side stick deflection is proportional to the yoke deflection as we climb or as we descend. Here also we have the thrust levers. You can actuate the thrust commanded by the engines moving forward. This thrust lever over here, or aft to the idle position as you fly. You will see the variation. I will show you in the display in a while, so you can control both the flight controls together, like in the HOTAS, the hands and throttles and stick. In the fighter jet, as you can see, we have full control, the rudder pedal. So you can see the thrust now commanded here. We have like 55%, and one which is low speed starter and low pressure compressor and turbine of the turbofan budget engine. The N2, which is the high-speed starter, static high-pressure compression tube, and with the turbofan towards its engine, the fuel flow per engine per hour, thousands of kilograms. Oil temperature, oil quantity, vibration, exhaust gas temperature. You can see some messages like in the Boeing 777, the flaps, the landing gear, and you can see the position of the horizontal trim here. The stabilizer trim, nose up and nose down. You can move the stabilizer trim nose up or nose down if you like. Also the rudder trim position, and also we have the fuel, I believe here, thousands of pounds gross weight and the total fuel gross weight and the total fuel and the fuel temperature. So we're gonna see a couple more things, more thrust if we need idle thrust also. So this is how you control both the flight controls with this side stick and the thrust levers. Also you have the horizontal trim stabilizer, so you can control the horizontal trim as you fly. The thrust levers, advance the thrust levers, pitch up slightly in the runway for takeoff, use the rudder pedals for nose wheel steering also, and use the horizontal trim. So we're gonna have a push back now for the aircraft. So I'm gonna show you also the outside view of the flight controls like this. So I'm gonna show you now the flight controls from the outside view, and then make the engine start demonstration, also the overhead panel and the other systems. So you can see here also we have the flight controls here of the Boeing 787. So you can see we can climb and descend from the outside view. Like this, you can climb and you can descend using the flight controls, the side stick. You can climb, descend, make turns to the left, make turns to the right, and use the rudder pedals or steering. So I hope you like the flight controls. Now we go inside for the rest of the systems. So I will show you the rest of the systems now. We have so I will show you now the overhead panel and the rest of the systems. Make the engine start demonstration. You will see a complete flight from takeoff, climb, cruise, descent, and approach and landing. So thank you very much for joining me in this video. I'm Hatsios, the German-American pilot flying the Boeing 787-900. Nice flight. So stay tuned until the end of the video. You're gonna see in the end part of this video complete flight from takeoff, climb, cruise, descent, approach and landing, full manual, and also a little bit of autopilot for this place. We go now for the rest of the systems. We have also a nice review here of the airport, as you can see, and the runways. So you can see the 787 here. The top view also of the aircraft. So we go now inside for the engine start. We have most of the systems. We have also this to aid us in some things. So we'll see the rest of the systems. The range here, you can adjust the range in this display. You can see the waypoints we have created. Flight plan. So maybe you can see the flight plan here better that we have to fly through. You can see the mountains here in front of you as you fly from takeoff. The distance they are located, also the waypoints we have to climb vertically. This display, the vertical deviation, and this is gonna be our waypoint path in the GPS as we're gonna fly from this runway. Also, you can see if you look more closely, we're gonna have the runway display here like this, the airport and the runway. You can see also the position we are located right now. You can see this taxiway we have here to turn right or left and use either runway 14 or runway 16. So you can see runway 16 over here is this way, runway 14 is this way, and they are both displayed here in the display. As you can see, both runways and the taxiway we have the curve of the taxiway. So we're gonna see also some systems. Here we're gonna have the systems display for a couple of seconds. So we'll see before takeoff we have the status, the hydraulic, the APU is off, so we need to see the APU in the overhead panel. So we have the electrical, left and right engine additive, backup generator, the battery. So we're gonna turn the APU on for making the engine start demonstration. We have the inertial reference here, the IRS and the ADIRU, the heading reference, normal or geographic or North Pole, the flight control surfaces ACES. This is flight control computers over here. So we have the flight control computers and the primary flight control computers to the auto. Here position, we have some other systems like the window heat, the passenger oxygen, the rammer turbine. This is a hydraulic system. I can show you if we turn off all the hydraulics what will happen. We have the lighting system here, the windshield wipers, the primary and the demand, the hydraulics over here, the fire extinguishers, the electronic engine control for the engines left and right, and the auto start system, the fuel jettison. We can dump some fuel if we arm this switch. We have also the crossfeed over here, and the fuel pumps. You can see the fuel pumps on and off, also the center pumps. Let's see what happens. Crossfeed valve. So this displays valve and this displays a fault in the balance. We have the wing and engine ADIs here. We have the cabin pressurization system, auto, manual. We use the outflow valves for climb and descent and select the landing altitude. And here we have the pressurizer from the APU and the left and the right engine. We need for hydraulic fluid pressurization, engine start, cabin pressurization, hydraulic fluid pressurization, and other systems. So we move that back to the idle. We have also the speed brakes. You can use all that to extend the speed brakes almost any time. We have also, this is the auto throttle disconnect switch like in the Boeing 777. We have the fire extinguishers for the left and the right engine, the fuel control to the left and the right engine, the flaps position here, up, retract and down. Also we have the parking brakes here set, the rudder trim, the transporter, the weather radar. So we're gonna have here the stabilizer cutout switch for if we have a failure of the CNDR stabilizer trim, just like in the Boeing 777. So use this trim to trim up the nose up and nose down. Also you have the automatic trim from the autopilot and the auto throttle system. So this is the horizontal tail here. You trim up and trim down in flight for pitch up and pitch down. The aircraft, you trim the whole surface up and down. It balances through the center of gravity and the forward winds, the minor dynamic chord position. So we have the flight controls also. We can see a couple more things. So the systems before starting the engines. We have the systems displayed. You can see the APU is running here, the hydraulic APU is running, oxygen, liquid cooling, electric left engine, right engine, the APU is running, the voltage of the batteries, here the main battery in the APU battery. We need the APU battery to start the APU. Hydraulics, left engine, right engine, 3000 psi, how much hydraulic fluid you have. Which systems use hydraulic pressure here. The fuel left engine and right engine, you can see low and high pressure fuel valves on, and feed from the left and the right wing tank with the fuel booster pumps. Also from the center tank we have a little bit fuel, so you can see the fuel in its tank. The fuel booster pumps, the crossfeed valves can feed either left and right wing engine with either tank or either pump if we lose a tank or we have a fuel tank leak or whatever, or a fuel pump. So you can use the APUs running using the fuel from the left wing using the DC motor, and the total fuel 33,900 pounds. And we have also the fuel temperature freeze, minimum fuel temperature minus 37 degrees. We can use the fuel safely above this temperature. The air left engine, right engine, you can see we can use load set air distribution. We need the flight deck passenger cabin. So this is also for air conditioning and for ventilation. For cabin pressurization, we need also for starting the engines. The doors are closed, the cabin can be pressurized. The landing gear, you can see the temperature of the brakes and the pressure of the tires. The flight controls, maintenance, FIS control panel, reset. We can set some systems here. So you use the flight controls. So here you can see the position of the flight controls as you're moving the yoke of the flight controls. You see the wings are working like this, but you also have you know how many degrees up or down, or the horizontal trim stabilizer, how many degrees. Maintenance, secret breakers, we have the secret breakers reset. So we go back to these systems and CDU info. We have some info. Checklist is just like in the 777 aircraft. Normal resets if we have a failure. Communications also like the 777 aircraft. And we go back navigation display for takeoff. So we're gonna make an engine start demonstration now. I'm gonna use maybe CDU. So we're gonna have CDU here, navigation display here. So we miss one display over there and one display over here. So we're gonna have this now the engine start demonstration. We're gonna need we have the APU running, so we need only to turn on the overhead panel here, the auto start to the on position. You can turn on both. So we'll turn off the engines first, turn off the fuel flow over here, turn both fuel. So we'll have both fuel off. The N1 is decreasing, exhaust gas temperature, you will see many messages now coming up. So you see the fuel flow is decreasing. And if we look outside the aircraft, we will see the engines both are stalled. Both the right and the left turbofans are slowing down, and they're off. So we need to turn on the auto start now to the start position. We can use both of them, auto start. So we'll see some reconfigurations happening in the systems. We have to wait the N2, which is the high speed starter, and the high pressure compressor is started emitting high pressure from the APU, from the auxiliary power unit. So we check outside, you will see both turbofans start spinning. So we have now reached the point we can start the fuel control on over here. So we have both fuel to the running, and both engines start. So we have both engines start now, both the right and the left. You can see the turbofans here spinning, the right and the left side. So we can now proceed for the takeoff over here of the aircraft, of the Boeing 787. So we have taken the clearance from the air traffic control. We can disarm the parking brakes like this. And then we can start taxiing to the runway. So we have disarm the parking brakes and advance the thrust levers and go. We have taken the air traffic control, the clearance from the tower, and we are ready for takeoff. So you can see if an aircraft is coming in. We can monitor in the navigation display, we can see an aircraft coming in, but we'll see it later when we go for takeoff. So we start rolling to the runway. Maybe advance a little bit more. And use this for steering of the aircraft. So we have started the initial roll, and we can taxi into the runway like this. The runway is open for us, and we are ready for takeoff. Align with the center line here. So parking brakes for a second. So we are ready for takeoff like this. You can see where we are and where we're going. And we have like 20 more minutes for this flight. So I'm gonna start rolling. Perhaps advance the thrust levers. I'm not sure. And go. So parking brakes are released. So we align with the rudder pedals with the runway. We have 90 knots. Use the rudder pedals for a line. 100, 90. V1, we rotate. So we rotate slightly. And here we go. Positive rate of climb, then retract the landing gear. As you can see, we climb, leaving the airport behind. So you can see the climb rate here. We're closer, 1,400, 1,600 feet closer to the ground. You can see the terrain map here in the navigation display, the modes we have to follow. So we climb barometric altitude 4,000 above the sea level, the airspeed, target airspeed. The engines here, the rating. So we need to configure the flaps a little bit up. So we can start the turn now. As we keep climbing, you can see the rate of climb here is positive. Keep climbing. So you can see as we climb out from Switzerland. So I'm gonna see now. So you decide a little bit. We need to make a little bit more turn here. So 11,000 feet. And this is the Boeing 787. So following the flight plan. So we follow the first waypoint now. Over here, direct 2. We can fly to the first waypoint as we climb. So hope you like the views of the Boeing 787. Also the Switzerland here, and the views from the galaxy, the star sign, as you can see, very beautiful star sign. So we're gonna cruise through these waypoints. You can see also the France this side and the Germany this side. We have the Bayern Munich, we have the lake. Over here we're gonna cross it in a while. So we have the waypoint very close, the first one. We need to make a turn now. We're flying out this waypoint. So we have to cruise through here. You can see we are very closer to the waypoint. We have crossed it, passing by. We're going for the next waypoint. We cruise to 35,000. We keep climbing now. You can see the airspeed and the stall speed here. The airspeed right now we have to level up for a while here for increasing the airspeed, and the stall speed 120 knots. So we keep climbing 23,000. You can see the arrow line is up. So we're climbing. So we are almost at 34,700 feet. We're gonna reach the cruise level in a while. We have the lake here, the St. Gallen Lake, I think. So we are here 35,000. So we will increase our airspeed a little bit. Also make some turns here, level off. So maybe we're gonna cruise even higher now, just to see the chemtrails. We will cruise like 29,000 feet. Keep climbing. We are at 35,000 now. 600, 36,000. So we're gonna have the chemtrails in a while, and the contrails. We'll see the frozen vapors. 36,000. We have to be overflying this waypoint and then coming back, but we can change come back faster, override this waypoint. So we are 600, still not having the frozen vapors. We are 27,000, the airspeed 141 knots, and now the next waypoint we have to be overflying here. You can see we have reached almost the altitude we need to climb, so we'll reach it when we reach this waypoint. As we keep climbing, we'll reach the roof of our flight. So we reach also 38,000 feet. We have the frozen vapors over here, as you can see. So we cross over the lake, beautiful lake with the Boeing 787, and we can level off here if we need. Start leveling off by climbing slower to increase the airspeed. So you can see the lake below, beautiful lake. The Germany ahead, the Bayern Munich region, and we have the France in this side, and the beautiful star sign. So we are 28,500 feet right now. You can see the frost on exhaust from the engines, frozen vapors. So we're gonna overfly maybe this waypoint and then come back for landing. We have also the Switzerland side. So we're gonna go now inside and have a view where we are with the cruise altitude and also the point we need to start that turn right here. So we're gonna start making a turn over here back to the airport. Follow the waypoints in the flight plan. Need to level off here. We're going manually, as you can see, leveling off here, and also increase the airspeed now. Maybe we need to retract the flaps we use for climbing fast. Also the airspeed need to adjust now again. I have also we can disconnect the autopilot if we wish. Take the manual control. So we reach 30,000 feet over here as we're trying to turn back manually, as you can see. We're gonna make a nice turn here. And I hope you enjoy the frozen vapors from the engines, the beautiful exhaust sound from the engines. You can see how nicely maneuverable it is. So we take in turn the Germany behind us, the Bayern Munich, and the France and Switzerland. So we're gonna cruise with about 980 kilometers, 900 kilometers an hour, or 300 meters a second in a couple of minutes here. This is made to cruise up like this. So we need to make an airspeed increase. We follow the flight plan again. We keep flying manually. We can also connect. So this is the airspeed limit now, Mach 0.75 or about 900 kilometers an hour. Gonna be flying through 29,000 feet here. So we have a higher Mach speed. We need also to pitch down a little bit. So you can see Mach 0.823 at 29,500 feet. The airspeed adjusted here, and the autopilot panel adjusted also. So it goes Mach 0.89, Mach 0.89 here, reach 0.895, 0.9. So we reach very high speed right now. We need to slow down a little bit because the speed breaks too fast. So now we're flying with Mach 0.9. Very high speed, almost 1000 kilometers an hour, and we cross here the star sign. Gonna start going down for the airport. In a while we have like 15 more 16 more minutes to go back into the airport. Hope you enjoy the view here. So this is our spacecraft view for tonight, the Boeing 787-900. We are a little bit over speed. So we cruise through 32,000 feet right now. Reach a little bit higher, 32,000 feet, and we're going back for the airport. So 32,000, and we're going back for a descent. We're over speed. We just decrease the Mach speed here. As we descend, make a turn now. Use the idle as we descend. And we're going through we can connect the autopilot if we need. So we connect the autopilot as we turn. We descend here 29,000 feet. So now we cruise and descend with the autopilot engaged. As you can see, we start the descent back into the airport. So we have a higher airspeed. We have to go through these waypoints here. We need to extend the descent rate and also the airspeed, vertical speed. So now we have the autopilot engaged and we're going back to the airport, as you can see. And we are 35,000 now. We went a little bit higher than we should. So we have to extend the descent. We have to elongate the descent before we go for landing. And we still have time for that. So we have the heading hold. Gonna use the LNAV now, and we're gonna turn for the airport. Back for the waypoints. We are much closer now, as you can see. 18,000 feet, and we have the autopilot on for this descending turn. And we're going for the airport, and we have like 13 more minutes to slow down the aircraft as we descend. Here we are going for the landing. So we'll be inside the waypoint, and we have a good chance also the warlock armed here, you can see. Also the computer here we use for approach and landing the waypoints. And here you can see the final approach path. We need to follow vertical and horizontal. We need also decrease the airspeed as we descend. So maybe use the landing gear down now here as we're descending. We have the autopilot now on to turn us into the airport. and hold us in the cruise. We're gonna disconnect it later as we are approaching in a couple of minutes. So we are much closer now. So we will adjust the airspeed like this. Also use some flaps now. Over here you can see the flaps moving down. Maybe we'll use the speed brakes up. We don't need the speed brakes. We are already slowing down right now. So you can see we are descending back into the airport. And we follow the line. We have to cross here. We're very close now to the airport and the runway. So we'll level off here for a while. 6,000. So we are 6,000 and we keep approaching for the runway. We need to use a few more flaps now. You can disconnect the autopilot like this and take manual control also. So we are aligned with the Lszh localizer, as you can see. I'm gonna use so we have the airport here. I'm gonna start descending to the airport. As you can see, we are aligned with the Lszh localizer. We need to start descending. A bit of descent. So we have the Lszh localizer, the airspeed, the Lszh localizer, glide slope here, and vertical rate of descent, and also the altitude we are right now. So you can see we are approaching for the landing here to the airport. So we're gonna have a nicer view like this of the aircraft as we're gonna make a touchdown. So maybe like this. We're gonna see the aircraft as it touches down the runway. So we are in a very good, nice position for the approach. You can see the Lszh localizer We are 2000 feet, 2200 above the ground, 165 knots, 3000 feet above the sea. All the modes armed, and the ILS localizer we are almost fully aligned. We have the airspeed also here, manual in the flaps set, so we're going with manual flight controls. As you can see, all flight controls now are manual. We add some flaps maybe. We need some more airspeed. You see also the runway like this, or like this. So here we are, almost reached the runway for the landing. As you can see, you can use a little bit less airspeed now as we are descending. Here we are, idle thrust, just touchdown, very beautiful touchdown, parking brakes and reverse, full reverse thrust, and we're slowing down the runway, need to align also. Here we are, very beautiful, landing and slow down with the Boeing 787. So you can see the nose wheel here is perfectly safe. There is no breakage of the nose wheel or the landing gear or the wheels here, the metal parts, both the left and the right landing gear and the nose wheel, all the metal parts and the tires are pretty much safe here. There is no blown tire from the landing or broken metal. So we did an excellent landing. All tires are normal. The front wheel and the landing gear behind it. So the aircraft can be used again for another flight. As you can see, starting up the way it should be. In the ground with all the wheels, forward and aft and forward wheels here. This is the front wheel. So this is the positions you have after landing. No, nothing is broken here, as you can see, all the tires and the wheels. So we did an excellent landing with the Boeing 787. So we cancel the thrust reverse. So you see all the systems are correct. So that was Thomas Hatsios, the German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport back to Zurich International Airport. Quality wings and flight simulator exit. So thank you very much for watching me. I'll see you next time. Bye bye. Bye. can see again the nose wheel and the landing gear. All the parts of the aircraft mentioned are reflected well and nice after